In section 7.4, we're going to talk about the properties of logarithms. So to start out, there's three main properties of logarithms, and they kind of follow the same properties that exponents have that we learned in chapter 6. The first property is the product property. If we have log base b of m and n, I could expand that to say log base b of m plus log base b of n. On the other hand, the quotient property, if we had something like log base b of m over n, I could expand that to subtract the two. So I would say log base b of m minus log base b of n. And finally, if I have a power on that exponent, so by the power property, if I had log base b of m to the nth power, I could kind of move that exponent as a coefficient, and I could say instead n times log base b of m. So we're going to use those properties to go back and forth between simplifying a logarithm into a simplified expression, and then further going from a simplified expression and expanding it. This is going to be helpful just to understand how these work with each other when we go into solving a logarithmic equation. So in this first example, I want to rewrite log base 4 of 32 minus log base 4 of 2 as a single logarithm. So in this problem, when I'm subtracting, by the quotient property, I could rewrite my equation to say this. Log base 4 of 32 over 2. Again, that's by the quotient property. From there, 32 over 2 is 16. So log base 4 of 16. And then from there, I could put this in my calculator, and I would find that log base 4 of 16 is equal to 2. In the next problem, I want to rewrite 6 log 2 of x plus 5 log base 2 of y as a single logarithm. Here, I'm dealing with variables, so I'm actually not going to be able to get like a nice numerical answer. I'm just simplifying this expression. So here, I have a coefficient in front, so that kind of tells me that I'm going to be dealing with exponents here. So I kind of move these exponents to the top of my expression. So I'm going to say log base 2 of x to the 6th power plus log base 2 of y to the 5th power in my first step. Finally, by the product property, since these are both taken to log base 2, I can kind of combine these to say this is log base 2 x6 times y to the 5th power. And that would be my final answer to simplify. Going the other way, here we're going to have a single logarithm expression, and we're going to want to expand it as much as possible. So in the first problem, I want to expand log of 4x over y. Remember also, whenever I see log and no base under it, that you can assume it's log base 10. It's not really going to be important in this problem though. So here I have log of 4x over y. So again, kind of moving by the quotient property, I know that whenever I see two expressions divided over each other, I could expand it to be subtraction. So I'm going to take those two terms, and then I'm going to expand them out like that. Finally, by the product property in that first expression, I could even expand log 4 of x to say log of 4 plus log of x minus log of y. There is nothing else that can expand here, so that is my final answer. In the second problem, I want to expand log base 9 of x to the 4th over 729. So again, I'm going to expand these by the quotient property, and I'm going to take the numerator and denominator and subtract them from each other. So I'm going to rewrite this to start as log base 9 of x to the 4th minus log base 9 of 729. From there, by the power property, I can rewrite that first expression as 4 times log base 9 of x. And then from there, in my calculator, I can just solve log base 9 of 729 because I'm not dealing with any variables there, it's just numbers. If I plug that in my calculator, I'm going to see that log base 9 of 729 is 3. After I've done all this, I see nothing else simplifies, so that's my final answer.